Welcome back to part 3 of this scenario based storytelling. And so today we look again part 1. That's part 1. Inside the gut does not. Inside the gut means into the stomach. That should be acidic if we are looking at meats. And if we are looking at carbs, it would pass through quite quickly here. That's why we have identified quickly that we have to understand there are only two substances that human beings are consuming. These two substances are plants and animals. Plants, of course, digest into glucose if it is, and fructose if it is. Well, not if it is, it directly could do that very easy, and that is generally what's happening. The other things from plants has to go through the same process as meats. Meats digest in an acidic stomach, so too plants have to digest in an acidic stomach if you have to extract out those minerals from the plants, and also if plants have anything else. Now the issue is, things like B12, protein being low. Science would tell you protein on a plant-based diet is low. You generally cannot get B12 from plants, and there's a lot to do with the availability of the plant not having B12, but the plant we know has some amino acids. So why is it low? Largely because plants do not stick themselves in the acidic stomach for proper soaking of plants over 2 to 3 hours. Plants cannot stay in the acidic stomach because they are so heavily glucose that they have to leave quickly. If you leave glucose in the stomach, then you are calling for bacteria to grow in the stomach, and when I say stomach, this one here. And if bacteria grow here, such as H. pylori, E. coli, Salmonella, we do have another set of problems, and we do have that when we are on a plant-based diet because of the same reasons. Plants would give you glucose in the stomach, which feeds those bugs. Now that comes down to the duodenum, and then you have digestion happening, which is nothing here to do with the bile because you are eating plants, so it goes into the small intestine, and that's where you get wetting of the gastric juices which came from the pancreas, and that would give us the digestion of carbs into glucose. Now all these things get absorbed into the villi, and that is where you have everything from the villi being sucked up into the portal vein up to the liver, and the liver start doing what is called the management to clean that which should stay, that the liver decides that he wants to keep. For example, glucose, it would say send it to the blood. I might store a little 10% if I need to. When there is enough, the liver wouldn't have anything to store because he said, I have enough already of this guy, I don't want more, just send everything into the blood. And we tend to have high blood sugar levels at this point in time. If it's something like fructose, the liver definitely cannot send it to the blood, so the liver says, I would have to handle this guy by myself. So the liver pulls fructose molecules, handle it for itself. If it's things like amino acids, it would just do what it has to do. Store some inside. B12, it would store some a little bit inside, hold on to a little bit for hard times, right? So it stores up. The liver is the one that stores up part of it for hard times. The liver also would get a whole onslaught of nonsense, which is things that come from the endotoxins or the waste of the bacteria that passes here. And if you have any gut related issues, which most of us do have in 2024, then they would send out a lot of toxins that go to the liver, and so the liver would try to detoxify them and push them into the bile. Again, the liver cannot do that. The liver is doing that with the support of key nutrients such as methionine and amino acid, minerals B3, B6, and other minerals and vitamins. The liver needs the same minerals to detoxify or to clean, to push things into the bile, to send it back out into the waste trap. Now that's in the liver. Of course, the liver job is not for the liver. The liver doesn't work for itself. Yes, it takes some to do it, but its goal is to send things into the copper pipes. Now the copper pipe is the blood system, so the liver goal is to send these things into the copper pipes, which is the best cleanest blood it could possibly create. And why it's doing that? Well, it's largely doing that because it wants to get these nutrients to the organs or the tissues. Of course, the organs and the tissues do not need the nutrients. It's not for them per se. It is for the cells that constitute the organs and the tissues. And really and truly, the cells do not want no nutrients. It is the mitochondria in the cells that needs the nutrients. Why? Because it's the mitochondria that it takes in the glucose, the amino acids, they consume the fatty acid, they do whatever with it, they manufacture it in whatever cycles, and they push out energy. For example, glucose, they put out the ATP, which is the real energy, and of course they make waste. So they put out two things, energy and waste. It's just like making cane sugar. You put out cane sugar and you put out alcohol or whatever you put out inside cane sugar processing. They do make waste, and they do make the nutrient or the energy or whatever we need. Whatever they do. I don't know what they do. The fact of the matter is, this is why all that we do here is important to understand, that we are trying to support the liver from this acidic stomach, not from the small intestine. The small intestine is not in the question. It's the acidic stomach that is the question, because what these guys need here is not just glucose. When you think about plants, you are only supplying mitochondria with glucose, and mitochondria does not need as much glucose as we consume. They have enough glucose, and they could get glucose just from the liver using other materials. The liver is smart enough to take anything and make it into glucose and send it into the copper pipes, which is the blood system, and get it in. And then once it goes in copper pipe, automatically to the tissues, into the cells, then into the mitochondria. So when we think about this big picture, we understand now we are going to mitochondria. And so in the next video, we will look at the copper pipes, which is what we are looking at now, how it goes into the organs, and the blood making a subtle come around here. The blood gets cleansed by the spleen, which is on the opposite side to the kidney. So this side cleans the blood when it enters here. That's the liver. Blood comes through the portal vein. Has nothing to do with the circulatory system. That's the entry of new food into new molecules, nutrient molecules into the liver. The liver is connected to the circulatory system. So when the liver cleans something and it stamps it, that's when it puts it in the circulatory system, which is the copper pipes. So this red pipe here has nothing to do with the circulatory system. It is the entry, the input system into the liver, and the liver is the one that determines, I would clean out these things and send these things into the blood flow, which is the copper pipe. The blood is always flowing. The copper pipe is always flowing. What is changing after the liver is what enters into the blood. Meaning, if you come up here with the blood, the liver would put 50 more molecules of glucose, 25 molecules of amino acids X, amino acids Y. So the copper pipes continue to run in the same direction, and they are running. Now when it reaches to the spleen, because there are organs between here and here, the spleen also now start picking up a set of things, maybe the liver missed, or things that came from other organs, because they may have spat back out or vomited back out some of the nutrients into the blood itself. So the spleen cleans that, and the spleen has a specific connection to the liver, another portal vein to the liver from the spleen to send waste here. So the spleen cleans the blood, and that's why the spleen is located on the other side, lower other side of the liver. Cleans the blood, spleen cleans the blood and sends it across here. And the good blood from the spleen, of course, goes to the kidney, which might have salts, metabolic waste. Well, no, salts, and these salts might get thrown out by the kidney. The spleen may also say, now there's too much of glucose, because this blood comes too much of glucose, so it may tell the kidney to do something. The kidney may expel some glucose if it could. It's not supposed to, but it might throw out some glucose. If you are kind of diabetic, you could pass some glucose through your kidneys, which is not the best thing to do. And then the blood goes back up to the liver. The liver does some work there too. If there is a lot of glucose, the liver might say, can I store some, if it has space? And that is where the glucose starts becoming a challenge. Now, of course, this is video number 3, and we'll look at video number 4 when things get into the organs.